Pune Local Center.
This meeting is being recorded.
Friends, this is our first program with Institution of Engineers in Pune and many more to come in future. Tech Forum is a group of technocrats who support each other. We have more than 100 members and we have presentations every fortnight. Today's presentation will be on hydrogen and fuel cells. You all know the future of automobile will be fuel cells, hydrogen fuel cells. And these are the technologies being driven in Japan and most of the countries. Mr. Sarolkar is going to throw light on this product, which is gaining popularity, and India also a lot of work is going on. Mr. Nandkishor Sarolkar is a mechanical engineer and postgraduate in management in two streams, production management and marketing management. Having wide experience over 44 years in industry and repute local as well as international market. Rather, he was in international market for 22 years. Last assignment was in India, MD cum CEO of German MNC, having 21 manufacturing plants, 4 R&Ds and centers and 2 tool development centers. Detailed biodata I have already circulated, so I will not spend time in telling that, but we have a very knowledgeable and practical and hands-on person for us today. And he takes a lot of assignments and he has a deep study in hydrogen and fuel cells. So before we start his presentation, we have Mr. Zope from Institution of Engineers, Pune Local Center. He is currently chairman. I'll request Mr. Zope to address the August gathering. Over to Mr. Zope, please.
Good morning to you all. I welcome you all on behalf of Institution of Engineers, Pune Local Center. Basically, all are aware, but I would like to take 2 minutes to introduce about the Institution of Engineers. Institute of Engineers is the largest multi-professional body, multi-discipline professional body. It came into existence in the year of 1935 by a royal charter. Pune Local Center is the first local center started by the Institution of Engineers. And our basic objective is that dissemination of the knowledge, information, technologies to the society, help them to the society in these areas. So we have got a good local center infrastructure on the Jangli Maharaj Road in front of Modern Cafe. We have got seminar hall, library, classrooms, seminar rooms. So everybody are welcome to join hands with us to meet our objectives. Jointly, we can conduct the programs such as Tech Forum is one of the best forum where we are joined and we are conducting. So I request all to visit at least once in the institution and see the infrastructure and will help us in conducting the program and we can jointly do that. Thank you so much, sir. And I hand over to the Robert.
Okay, thank you, Zope sir. Mr. Zope is currently chairman of Institution of Engineers, Pune Local Center, which is located at Shivaji Nagar, Jangli Maharaj Road. And we will be signing a MOU very shortly for joint ventures and joint activities because we have a lot of activities in common. So this is the first program we have organized on fuel cells. The next program will be on Tuesday, 17th. We will be celebrating World Telecom Day. On 17th, in association with Pune Hams, Tech Forum, Institution of Electronics and Telecommunication Engineers, and of course, Institution of Engineers, Pune Local Center, it will be offline, live in Pirodia Hall of Institution of Engineers. It will start at 5 o'clock and around 7:30 it will be over. We will be having Mr. Vinit Mathur, who will be talking about the World Telecom Day, and our ham, Mangesh Patil, V2 Oscar Mike, will be presenting on the fastest mode, rather sure shot mode of telecommunication, rather radio communication, FT8, which gives the sure shot communication. It is also used for Earth-Moon Earthbound. So don't miss this program because we will be having a live demo. Now, without spending much time, I will hand over the mic to Mr. Sarolkar for his presentation, hydrogen and fuel cells. Over to Mr. Sarolkar.
Thank you, Mr. Vilas, and good morning to everybody who is present. I welcome Mr. Zope, Chairman of Institute of Engineers, and I begin my presentation. When I was talking to people in general about hydrogen, fuel cell, and other technologies, I found that there is a lot of people are not aware and they have a lot of confusion. So in this program, we will try to give some basic information about hydrogen and fuel cell technology. This is only a basic and not in detail, in depth, because in 1 hour we cannot cover this subject as a whole. Now, as we know all, hydrogen is the simplest and the most abundant element in the universe. Hydrogen is major component of water, oil, natural gas, and all other living matters. Despite its simplicity and abundance, hydrogen rarely occurs naturally as a gas on the earth. It is almost always combined with other elements. Hydrogen in the air is only at about 0.55 ppm. So when we say that hydrogen is available everywhere, yes, it is available everywhere, but it is not available in the air. Hydrogen can be generated from oil, natural gas, biomass, or simply by splitting water using standard technology or renewable or solar energy. Once hydrogen is produced as a molecular hydrogen, the energy present within the molecule can be released by reacting with oxygen to produce the water. Hydrogen, therefore, is an energy carrier which is used to move, store, and deliver energy produced from other sources. Hydrogen is a clean fuel. When consumed in a fuel cell, it produces only water and no other pollutants. In a fuel cell, hydrogen energy is converted directly into electricity with high efficiency and low power losses. Hydrogen can be produced from a variety of domestic resources such as natural gas, nuclear power, biomass, renewable power like solar, wind, etc. These qualities make it attractive fuel option for transportation and electricity generation applications. Hydrogen can be used in cars, in house, for portable power, and for many other applications. Today, hydrogen fuel can be produced through several methods. The most common methods today are natural gas reforming, which is a thermal process. And second one is the electrolysis. Other methods include solar-driven and biological processes. Thermal process is a process of hydrogen production typically involve steam reforming, a high temperature process in which steam reacts with hydrocarbon fuel to produce hydrogen. Today, approximately 90% of the hydrogen is produced from steam reforming of natural gas. The second, which is most common, is electrolytic process, where water can be separated into oxygen and hydrogen through a process called electrolysis. Electrolysis process takes place in electrolyzer, and in this process, conventional pot water, marine water, or sea water can be converted into hydrogen. The next process is a solar-driven process, where solar-driven process uses the light as the agent for hydrogen production. It is something similar to our solar power generation. There are few solar-driven processes, including photobiological and photoelectrochemical and solar thermochemical processes. Photobiological process use the natural photosynthetic activity of bacteria and green algae to produce the hydrogen. Whereas photoelectrochemical process use specialized semiconductors to separate water into hydrogen and oxygen. Solar thermochemical hydrogen production uses concentrated solar power to drive water splitting reaction, often along with other species such as metal oxides. The next one is a biological process. Biological process use microbes such as bacteria and microalgae can be produced hydrogen through biological reactions. In microbial biomass conversion, the microbes break down organic matter like biomass or wastewater to produce hydrogen. While in photobiological process, the microbes use sunlight as the energy source. So in this process, the wastewater also can be converted into hydrogen, and this could be one of the interesting process according to me. We all know hydrogen is not a primary energy source because it is not naturally occurring as a fuel. It is, however, widely regarded as an ideal energy storage medium. Due to the ease with which electric power can be converted water into its hydrogen and oxygen component. The electrolysis can be converted back to electrical power using a fuel cell. Hydrogen fuel is a zero carbon fuel burned with oxygen. It can be used in fuel cell or internal combustion engine. As of 2020, the majority of the hydrogen is produced from fossil fuel. Pure hydrogen does not occur naturally on Earth. It requires primary energy input to produce on the industrial scale. Steam and methane reforming are the current leading technologies for production of hydrogen into large quantities. Extract hydrogen from methane. However, this reaction releases fossil carbon dioxide, carbon monoxide, which are greenhouse gases. So we cannot say that hydrogen or hydrogen fuel cell is completely green process. When we are producing hydrogen, yes, there are some pollutants or some greenhouse gases generated. Production is usually classed in terms of color, like gray hydrogen, blue hydrogen, green hydrogen, etc. So what is this gray hydrogen or blue hydrogen or green hydrogen? Gray hydrogen is basically produced as a byproduct of industrial process. Blue hydrogen is produced through a production process where CO2 is also produced and which is subsequently captured as CCS. And finally, we are talking of green hydrogen, which is produced entirely from renewable sources. Globally, the hydrogen prices are coming down due to improvement in water resources and hydrogen fuel cell technology. The Paris-based International Energy Agency expects the cost of production of hydrogen to fall by about 30% by 2030. However, the rapid reduction in the cost of recent EV energy projects in Middle East could mean the local cost of the commercially producing hydrogen will fall for even faster. As investment in hydrogen infrastructure grows and the net cost continues to fall, the hydrogen economy could prove to be an indispensable tool in the transition away from the hydrocarbons. This means that since the cost is coming down, the hydrogen vehicles can be seen very soon on the road. Now a question comes to my mind or to in general person's mind, why we talk of hydrogen fuel cell? Why not, if we are converting fuel cell and using hydrogen as a basic material, why not use hydrogen itself as a fuel? The hydrogen efficiency to the wheel is about 25%, whereas the fuel efficiency is about 60%. Means if we use hydrogen directly for converting or for running the vehicle, the efficiency is only 25%, whereas when you use hydrogen as a fuel cell, the efficiency to the wheel is 60%. The other problems are like hydrogen boils at minus 253 degrees centigrade, whereas the critical point is at minus 240 degrees centigrade. And as such, it is very, very difficult to store the hydrogen. Hydrogen storage is difficult, hydrogen transportation is difficult. 1 liter of liquid hydrogen is equivalent to 851 liter of gas. You can imagine the difference. And hydrogen cylinders which you require, they are supposed to be very, very strong. For liquidification, hydrogen needs to be compressed to more than 350 bar or 5000 psi. Hydrogen has very high flammability when it is mixed with water, mixed with air. It starts flaming when it is between 4 to 76% of the ratio. Whereas the conventional fuel like petrol and diesel needs a ratio of only 1.4 to 7.6. What does this mean? This means that the space required for burning hydrogen is quite high compared to the fuel, and that is one of the reasons why hydrogen is not used directly as a fuel. The second and very important reason, the hydrogen flame speed is more than 10 times compared to the fuel burning speed. Hydrogen requires high auto-ignition temperature like 500 degrees centigrade, whereas the petrol is about 220 to 300 degrees centigrade. Hydrogen has high diffusivity and low density. It gets mixed with atmosphere very easily. Hydrogen has a small quenching distance. It means it fires very close to the combustion chamber and needs very efficient thermal management system. Air is again a limiting factor as the hydrogen occupies very high space in combustion chamber. Hydrogen requires direct injection. It requires aggressive crank press ventilation and aggressive exhaust gas recirculation. It requires very efficient heat removal or thermal management system. There is a danger of pre-ignition and backfire in hydrogen system. Second very important aspect, that the IC engine cannot be retrofitted directly for the hydrogen fuel. When we use hydrogen as a fuel, there is an emission of nitrox, carbon monoxide and carbon dioxide. In order to avoid these contaminations, we need to use the catalytic converter. If we want to control the nitrox production, the 50% power is underrated. Otherwise, the nitrox is beyond permissible limit. And in such case, the tank to wheel power ratio is dropped down to 25%. And this is one of the main reasons why fuel cell is important, or why we use fuel cell. Now, what is fuel cell? Fuel cell is a device that generates electricity through an electrochemical process and not by combustion of the fuel. In fuel cell, hydrogen and oxygen are combined to generate the electricity, heat and water. Fuel systems are clean, efficient, reliable and quiet source of power. Fuel cells do not need a regular charging like batteries, and instead it continues to produce electricity as long as the fuel source is provided or as long as the hydrogen is available. A fuel cell is composed of anode, cathode and electrolyte membrane. Typical fuel cell works by passing hydrogen through the anode of a fuel cell and oxygen through the cathode. At the anode side, a catalyst split the hydrogen molecules into electrons and protons. The protons pass through the porous electrolyte membrane, while the electrons are forced through a circuit, generating an electric current and excess heat. At the cathode, the protons, electrons and oxygen combine to produce water molecules. As there are no moving parts, fuel cell operates silently and with extremely high reliability and efficiency. So in short, fuel cell is something similar to our conventional cells, what we use for our battery or other purpose. So what we can say, the fuel cell works like batteries, but they do not run down or they do not require charging. They produce electricity and heat as long as the fuel is supplied. Means as long as we supply the hydrogen and it passes through the membrane, get reacted, then we produce the electricity. The electrons, when pass through the external circuit, creates a flow of electricity. The proton migrate through the electrolyte to the cathode where they reunite with oxygen and the electrons to produce the water and the heat. So in short, when we supply hydrogen to the fuel cell and produce energy, the only pollutant or the only byproduct is a water. Now, when we say fuel cell, are there multiple types of fuel cells available, or it is only one standard particular fuel cell which is used everywhere as a common? No, it is not only one type of fuel cell. There are different type of fuel cells having different type of applications. And these fuel cells, although work on a basic fuel cell principle, there are special varieties developed to take the advantage of different electrolytes and different applications. Some of the fuel cell types are polymer electrolyte cells, which operates at relatively low temperature and can quickly vary the output to meet the shifting power demand. These polymer electrolyte cells or polymer membrane cells, they are commonly used for the automobile application. The other cells are direct methanol fuel cell, alkaline fuel cell, phosphoric acid fuel cell, molten carbonate fuel cell, solid oxide fuel cell, combined heat and power fuel cell, regenerative or reversible fuel cell. Now, all these fuel cells have different applications and different electrolytes. The fuel cell uses the chemical energy of hydrogen or other fuel to cleanly and efficiently produce the electricity. If hydrogen is the fuel, electricity, water, and heat are only byproducts. Fuel cells are unique in terms of variety of their potential application. They can provide power for system as large as a utility power station or as small as a laptop computer or even for the mobile. Why we use fuel cells? Fuel cells can be used in wide range of application, including transportation, material handling, stationary power or power storage, portable power application, emergency backup power applications, etc., etc. Fuel cells have several benefits over conventional combustion-based technology currently used in many power plants and passenger vehicles. Fuel cell can operate at higher efficiencies than combustion engines and can convert the chemical energy in the fuel to electrical energy with efficiencies up to 60%, which is considered to be very, very high. Fuel cells have lower emission than the combustion engines. When we say lower emission, practically the emission is not there in the manufacturing or when fuel cells are used. The outcome or the byproduct is. Hello. Hello. I'm audible.
हो आवाज येतोय तुमचा मध्येच ब्रेक आला पण आता तो गेला.
Somebody switched on.
Is it okay now?
Please continue.
Perfect.
So what happens when hydrogen fuel cell emits only water? Then why we say that there is some emission? Emission comes only when we are generating the hydrogen, not when we are burning hydrogen as a fuel cell input material. Hydrogen fuel cells emit only water. So there are no carbon dioxide emission and no air pollution that creates smog and cause health problems. Also, the fuel cells are quiet during operation and they have very few moving parts. So fuel cells are definitely a better option. Now, efficiency of fuel cell, as we discussed, is generally high, and it is between 40 to 60% efficient. When we say 40 to 60% efficiency, mean we talk of input energy at the fuel cell level and output energy to the wheel. This is definitely very high because the IC engine has a efficiency to wheel is at about 25% only. In combined heat and power application system, the heat produced by the fuel cell is captured and put to use, increasing the efficiency up to the level of 85 to 90%. The maximum theoretical efficiency of fuel cell is 83%, operating at low power density and using pure hydrogen and oxygen as reactants, assuming that no heat is captured. In a fuel cell vehicle, tank to wheel efficiency is greater than 45% at low load, and it shows that average value of about 36% when we have heavy loads or when we go at a very high speed and something like that. So this is something when we say that the average of the vehicle is tested at a standard running condition, and the actual average goes down when we are running vehicle on the streets. Fuel cell vehicles running on compressed hydrogen may have power plant to wheel efficiency of only 22% if the hydrogen is stored as a high pressure gas, and 17% if it is stored as a liquid hydrogen. Honda has done a lot of research and released a demonstration fuel cell electric vehicle named at Honda FCX Clarity, with a fuel stack coming to 60% tank to wheel efficiency. And this is really a very, very good efficiency if we say. Now, what are the important factors in hydrogen fuel technology? The four main areas which are affecting or which are driving the fuel cell technology is the technology, environmental impact, social impact, and economic reasons. In technology, feasibility of the technology, efficiency of the fuel cell, reliability of the fuel cell, these are important aspects. Whereas in environmental, decrease in the waste and toxic waste, no pollutant, etc. Greenhouse emission gas is not produced. These are important aspects. In social, public acceptance is really important, but I personally feel that the required awareness about hydrogen and hydrogen fuel cells is not in India, and we need to do a lot of work to create the awareness. This is definitely going to improve the quality of life. However, there are lack of experts and lack of knowledge available. So the academia needs to do a lot of work in this to produce the required technicians or required skill. This also has a very high employment generation, and if academia start courses in hydrogen or hydrogen fuel cell, I think it is definitely going to help them in long run. Now, what are the economic considerations? The production cost of hydrogen is definitely very high, but the running cost of the fuel or running cost of the vehicle or the cost of the fuel per kilometer run is definitely very, very low. So you have initial high cost and you have very low operating cost. So the low operating cost in long run can offset the initial investment required or initial infrastructure capex required. Since there are no moving components or very low moving component compared to the IC engine, the maintenance cost is definitely very low compared to IC engine. Life cycle cost is not yet worked out, but definitely it is going to be less compared to the IC engine cost. And ultimately it needs to create a value. Now, what are the strengths and weaknesses of a fuel cell technology? When we talk of fuel cell, we need to consider the strength and weakness of the fuel cell technology. I do not have any slide here indicating that, but I'll give you a brief strength and weakness on the fuel cell technology. If we see the technical strength of the fuel cell, hydrogen has the highest energy per mass unit of the fuel type. Means 1 kg of hydrogen contains as high as 2.1 kg of natural gas or 2.8 kg of oil. Fuel cell has an overall efficiency of up to 60%. Fuel cell converts hydrogen directly into electricity and heat. Hydrogen can be transported to long distances, stored in various forms, etc., etc. If we consider the environmental strength, it is an inexhaustible source, and hydrogen production and consumption is a closed cycle. Burning of hydrogen almost entirely devoid of pollutant or emissions. Hydrogen is non-toxic energy transport operation. Hydrogen is environmental friendly and reduces the amount of greenhouse gas generation. Power generation with hydrogen produces low noise compared to other systems. If we talk of sustainable development of the strength of hydrogen, then hydrogen could be considered as a never-ending source of energy. Hydrogen is a non-polluting energy carrier. Hydrogen power has huge development potential because it can be used right from mobile to cryogenic engines. Means the application is everywhere and anywhere. We need to explore the possibility of using it and having a suitable engine or suitable technology to use the hydrogen as a gas. Now, hydrogen can be obtained from a variety of primary renewable energies. Hydrogen is only secondary energy carrier that is suitable for wide applications like stationary batteries, transport, or portable domains, etc. It has a diversity in resource harnessing also. Hydrogen can be obtained from a wide range of primary energies. And very important thing, hydrogen decreases the dependency on fossil fuel and increase the alternative energy diversity. Now we talk of strengths of the hydrogen. Now what are the opportunities in the hydrogen business? Yes, there are a lot of opportunities, like hydrogen is a key element for future green sustainable development. Hydrogen can be considered as an object of innovation and technological development along the lines of energy efficiency. Hydrogen use encourage the generation of green energy from indigenous and unconventional sources. Hydrogen fuel cell technology can be considered as a next energy efficient solution. Hydrogen fuel cell technology stimulates research, innovation, and development in energy system domain. Hydrogen system and hydrogen fuel cells improve the energy security. In short, hydrogen is expected to play an important role in global future energy scenario. So, hydrogen is going to be a very, very crucial subject in future, whether it is automobile or whether it is general power supply or whether it is emergency power backup. Now we have discussed the strengths and opportunities of the hydrogen system. So are there any weaknesses in the system? Naturally, there are some weaknesses, which are something like unavailability of efficient hydrogen infrastructure. The infrastructure includes production, storage, transportation, etc., etc. Currently, we do not have a hydrogen production facility. We do not have hydrogen transportation facility. Unfortunately, the existing CNG gas work or natural gas work cannot be used for hydrogen directly. If we see, the hydrogen is produced in European countries at the back door of the fuel station, and the hydrogen filling station is operated. So it will require establishment of hydrogen generation plant just very close to your fuel pumping station or your hydrogen pumping station. The integration of hydrogen as an energy carrier into the energy system is not tested on an industrial scale. This is one of the very important issues, because we talk of hydrogen fuel, hydrogen benefits, everything. But has anybody used hydrogen power for industrial application where the requirement is huge? So in short, it is not yet tested. Again, the lack of effective infrastructure for introduction of hydrogen in existing transmission will create a problem. The major weakness, hydrogen can burn in the presence of air, and which can cause operational safety issues. So safety is one of the prime important factor when we talk of hydrogen. And hydrogen as a fuel is not well accepted by public as on today, because the first thing, there is no education. The society is not educated about the hydrogen usage, and it is not available anywhere. So there is no way how the society will know what are the advantages or what are the disadvantages of the hydrogen. The hydrogen storage technology is definitely costly, and if we consider CNG tank and hydrogen tank, the cost of the hydrogen tank is very, very high compared to CNG tank, because it requires to withstand very high pressure. And hydrogen tank weight is more than the weight that it can carry the hydrogen. Now, what are the threats? The threat is basically immaturity of some technologies for conversion of hydrogen, lack of experts for implementation of hydrogen technology, lot of skills or lack of skill for operation and maintenance of the hydrogen vehicle, insufficient storage capability in large quantities of hydrogen, immature solution for large-scale hydrogen storage, limited practical experience in both production, producers, and consumers. The strong fossil fuel market makes it difficult to compete. And we all know that the fossil fuel market lobby is very, very strong, and it doesn't allow alternate fuel to enter into the market very easily. If we consider, then what are the prices of the vehicle or the technology? The hydrogen fuel cell vehicle approximately cost about 60,000 pounds or 60,000 euro, whereas electric vehicle sedan will start at 21,000, and petrol or diesel vehicle will start at about 8,000. If we talk in Indian rupees, the petrol diesel vehicle average price is about 5 to 6 lakhs rupees, whereas electric vehicle price is above 15 lakhs rupees, and hydrogen fuel cell will be approximately 50-60 lakhs rupees. So no doubt the initial cost of vehicle around today is very high, but these prices are definitely going to drop down in near future. Now, how the fuel cell is working? We have discussed everything, but we have not discussed how the fuel cell is working and what is the difference between the fuel cell and the conventional electric vehicle. So, like all electric vehicles, fuel cell electric vehicle also use the electrical power to run. But what happened, instead of drawing electricity or energy from the battery, the fuel cell use the energy from the fuel cells, and batteries are used only to store the regenerative energy or supply during the peak demands. Amount of energy stored on board is determined by size of the hydrogen fuel tank in case of hydrogen fuel cell vehicle, whereas in case of electric vehicle, we determine the capacity by battery kilowattage or the battery capacity installed in the vehicle. So this is a brief difference in the hydrogen and the electric technology. Now, if we see the difference between fuel cell and electric vehicle, the electric vehicle has electric traction motor, power electronic controller, DC-DC converter, thermal system, that is heat management or cooling system, the battery, onboard charger, the transmission, charging port, and the battery pack. Whereas in hydrogen fuel cell, you have the fuel cell stack, which is replacing the conventional battery used for the traction, the electric traction motor, the DC-DC converter, the thermal system management, that is again the cooling, etc., the auxiliary battery, the power electronic controller, and transmission. So majority of the components are same in electric vehicle and fuel cell electric vehicle. Only the traction batteries, which are used for giving energy to the battery to the motor, are replaced with fuel cells. Now, as shown here, these are the basic components of the fuel cell electric technology. These are power control unit, motor, fuel cell boost converter, fuel cell stack, high pressure hydrogen tank, and battery. So these are the basic components which are used for the hydrogen system or fuel cell electric vehicle. Now what happened? The electric vehicle we can charge either with the solar or with the electricity which is available, and electric vehicle will use the energy from the batteries. Whereas in case of hydrogen system, you have to store the hydrogen, and the stored hydrogen you need to pump into the vehicle for use into the fuel cell. Now, what are the issues with the fuel cell vehicle? Is there any issue or it is perfectly all right? So yes, there are some issues with the hydrogen fuel cell vehicle, and the technology as on today is not a mature technology, and majority of the car manufacturers are working on it to make it popular and cost effective. What are the issues then? The issues are something like that. First is the driving range, because the quantity of hydrogen which can be stored on board is limited, and it gives a limited range. The second is the environmental adaptability. What happens if the temperature is sub-zero? What problems it will have in starting and the heat dissipation at high temperatures? The next is the performance. When we talk of performance, the fuel efficiency to the wheel is dropped down basically because we add on a lot of weight to the hydrogen cylinder. In order to minimize that weight, or in order to improve the performance of the vehicle, majority of the automobile owners, manufacturers are working for the size reduction and weight reduction. The next important issue is the reliability and durability of the hydrogen fuel cells. There are a lot of actions and a lot of activities are going on in this respect. The next point is the quality control and the cell uniformity. As we discussed, the hydrogen fuel cells are using a membrane to separate electrolyte, anode and cathode. The membrane made out of same material manufactured by different manufacturer will have a different efficiency. So the cell uniformity is yet not achieved, and this also needs a lot of work to be done. Another important point is cost of the vehicle. Initial cost of the vehicle is very high, though the operating cost is comparatively low. But in country like India, people will always think of initial cost, and the automobile manufacturers are trying to reduce the platinum use for mass production technology and bring down the cost of the equipment. Let's hope that the cost will come down very soon, and we will have a vehicle which can be affordable to normal public. Now, what are the efforts they are doing to improve the performance? The efforts in doing the performance are basically downsizing the fuel stack, improving the power density, improving the power train for lower weight and dimension, as well as for higher efficiency. I would like to mention here that Hyundai has successfully downsized its fuel stack by almost 33%, maintaining 130 kilowatt of output with power density of 3.1 kilowatt per liter, which is approximately 60% improvement in their earlier vehicle. The compact fuel cell systems and the drive unit is a combination of Hyundai, and it is one of the really good things. By end of year 2019, about 18,000 fuel cell vehicles had been leased or sold out worldwide, and 3 fuel cell electric vehicles were introduced in the commercial market. One of them is Honda Clarity. The next one is Toyota Mirai, which is bought in India by Nitin Gadkari. And the next one is Hyundai iX35 fuel cell electric vehicle. Honda is also coming out with a new model named FCX Clarity. Mercedes-Benz has already tested Mercedes-Benz F-Cell model in Europe, and they have claimed a performance of 1,000 kilometer in one battery, or we can say in one not battery, one tank of the hydrogen. Japan is leading in the fuel cell technology implementation. The country has over 100 refueling stations and have already been established. Government in Japan is aiming to 800,000 fuel cell vehicles on road by 2030, which will reduce 90% reduction of cost of the hydrogen by 2050. Fuel cell technology can be especially useful for commercial applications where heavy vehicles need to be traveling long distances and carry loads. Now, we discussed that hydrogen cannot be used as a fuel directly for vehicle, and why the fuel cells are required. So, if these are the things, fuel cells are necessary, then what are the business opportunities available for the fuel cell in India, or business opportunities available for hydrogen system in India? Yes, there are a lot of business opportunities available, which can be broadly distributed into three manufacturing heads or three heads. One of them is hydrogen manufacturing. Now, how do we manufacture hydrogen? Whether it is through natural resources, whether it is through electrolysis of water or something else. That will decide on the technology required for manufacturing of the hydrogen, the infrastructure required for manufacturing of hydrogen, and the capex required for manufacturing. So hydrogen manufacturing is one of the main head. The second business opportunity can be manufacturing the hydrogen fuel cells itself. Manufacturing hydrogen fuel cell is something similar to manufacturing the conventional batteries. And the manufacturer again needs a lot of infrastructure and other capex, etc., which will govern by the type of fuel cell he intends to manufacture, the volumes what they are initially looking, and the volumes that can be absorbed by the market. The third area is the manufacturing of high pressure hydrogen tank, because each fuel cell vehicle will require a hydrogen tank, like each CNG vehicle requires a CNG tank. So the tank manufacturing also is a very important business. The difference between conventional system and this hydrogen tank is that the hydrogen tanks which are going to use for this process are required to be very high pressure resistant tanks. The pressure required for testing will be more than 10,000 psi. We have very good contacts in European established business house who is already in the business of hydrogen and fuel cell. If there is anybody interested for doing this business in India, we can connect the partner, and the European company is also interested to spread their wings in India. With this, I end my presentation, and I hope that I am in a position, or I have given a basic information required for the technology to the general people.
Thank you, sir. Wonderful presentation, I must appreciate. I had been to Japan in 2019 to witness what Japanese and Koreans are doing. And I found Koreans were partly working on the electric vehicles and partly on hydrogen. But in Japan, they were all working on hydrogen and hydrogen fuel cells. That your presentation confirms that. Thank you very much for this wonderful inputs to the August gathering. And the problems in the fuel cell technology are the opportunities for Indian manufacturers and new entrepreneurs. And I'm sure on behalf of Tech Forum, you will definitely guide them, those who want to start their businesses. Thanks a lot. Before we go for question and answer, I would like to request all the participants to identify their names and then ask the question. So over to participants for Q&A session. Dr. Sanjeev Karti.
Am I audible?
Yeah.
Okay.
Yes, yes. I would like to request Dr. Sanjeev Karti to give expert comments because he has worked in this field and he is FRSC. So, Dr. Sanjeev, please go ahead.
Okay. First, I have two comments, and then I have a question for the speaker. First, hydrogen production is done on a ton scale at all the most of the refineries, because hydrogen is required there. So we do have hydrogen production hello, can you hear me?
Yes, sir.
Yes,
Your
yes.
Your
audio.
voice is very low, sir. Your voice is
Suddenly,
very low.
suddenly something happened and my thing is showing
Sir, you are audible. You are at right. I am able to hear you very
okay.
clearly. Please
ठीक है.
continue.
Okay, so hydrogen production from, as you mentioned, steam methane reforming is done at all the most of the refineries in India, including MRPL and Reliance and HPCL, IOCL, you name it. So hydrogen production and the cost there is about $2 per kg of hydrogen, somewhere in that range. So if we use that hydrogen to start with the fuel cell, I think it will be called a blue and not totally green, but it is still greener than using the diesel or petrol kind of things. That is one. Number two, HCNG, as it is called, is a blend of 17% hydrogen and the rest is CNG. So that's why it is called HCNG, and that can reduce emissions and a lot of other things. But more importantly, we can set up the distribution system for the production distribution system for this blend instead at all the CNG stations. And I think that is in the roadmap for the country. So we'll start with and this HCNG can be used in all the CNG based vehicles today. Number three, now you mentioned many times, which is correct, the cost of the fuel cell vehicle is very high and running cost is low. Could you give an idea about if I can produce hydrogen at $2 per kg, what would be a running cost of the fuel cell vehicle, say per kilometer or 100, whatever this thing? And so that is my question. And the next question is, what is the membrane life in both hydrolysis, which is the production of hydrogen, and the secondly in the fuel cells itself, because fuel cell is running at much higher temperatures, and the PEM, polymer PEM membranes that are used, that becomes a major cost for running the fuel cell vehicles. Please, I suggest you please make comments on these 2 points. One is the hydrogen production at $2 per kg. What would be a running cost of a fuel cell vehicle? And the membrane cost replacement, any experience with running fuel cell vehicles over a long time? Thank you.
Yeah. The Mercedes-Benz vehicle, which had a 6 kg of fuel tank, has given a 1,000 kilometer of the range. So if we consider $2 per kg, then $12 has given a 1,000 kilometer run. That is first. The second thing, what you ask is the life of the membrane. I am not fully aware of the life of the membrane, and I think that the studies on the life of the membrane are still going on, because every now and then the new membranes are being developed. I will try to get the information on the life of the membrane and come back to you, sir. But just for your information, there is a company in Pune also who has developed their own membrane.
Okay. Can you name the company?
I really don't remember their name, but I will have to look into the my data, and I can come back to you.
Okay.
Thank you, Nandkishor ji,
Thank
for
you.
very
Okay,
good.
thank you, Katti sir. Any more questions, please?
There are questions in chat box. If anyone is not there, we can address that also.
No, all are present. Any more questions, or the subject is very clear?
Mr. Chaitanya Kalapure, you had some questions mentioned in chat box. Can you please pick out yourself?
Yeah.
Chaitanya, please go ahead.
Yeah. Am I audible, sir?
Yes,
Yes.
very much.
Okay. Yeah. First of all, thank you very much. It is an excellent, presentation. This topic is also nowadays very hot topic in the market because we are finding alternative to our, the normal fuels on which our cars are running. So I have a couple of questions for, the speaker. The first question is this hydrogen cell technology for cars. Actually, I remember in the college days also during the final projects or maybe thesis what we submitted. So some of some of the members, they have done this particular thesis or project on hydrogen and fuel cell for car. So first question is why it is taking say 15 plus years to making that idea as a reality, even when we are in the fastest moving world nowadays where the research is happening everywhere 360-degree. So are there any challenges we have heard about certain challenges, but what makes it more challenging, and whether in next say 5 years down the line, can we see these cars running on our roads? This is my first question.
If we see, the fuel cell technology was commercially deployed in Europe at least 8 or 10 years before. In 2015 Frankfurt show, when our Prime Minister Narendra Modi declared Make in India, that show there were commercial vehicles and the fuel cell cars which were tested by our government officials, including Modi ji, Nitin Gadkari ji, Devendra Fadnavis ji, etc. The technology, as far as my opinion, has not come to India because we Indians are not taking lead in the development, and we hardly spend anything on research and development. We have a mentality that let somebody else start new business or the new product, let him take risk. When he starts making money, then I'll jump into the same business. Let my margins go down, but I will not have a risk of failure. To my opinion, this is one of the main reasons why hydrogen technology has not come in India all these days. I may be wrong, but this is my own reading. Now, question of whether we can see hydrogen vehicles on road in next 5 years, I have my own doubts because the infrastructure required for hydrogen is yet not available. And making hydrogen available on the petrol, on petrol station or the hydrogen station, require a huge investment. The transportation of hydrogen is a difficult task. So whether government should do that investment or the individual should do that investment is again a big question. So government has to come out with a clear policies, and then only we can say that the hydrogen vehicles on road will be a reality.
Okay. Thank you very much, sir. Thank you.
Okay. Thank you. Any more questions? I think we can take the last questions and then I will make few announcements. Okay, there are no questions, friends. It was a wonderful presentation from Mr. Sarolkar. I must appreciate his well-studied efforts, and he has given an in-depth knowledge, rather basic inputs on fuel cells. Friends, Tech Forum is a like-minded forum for like-minded intellectuals and entrepreneurs, scientists, researchers, and we support each other. And there are opportunities available, so which we share, and those who are seeking for opportunities, they get these inputs. We conduct every fortnight a technical presentation